So in this chapter, we're going to talk about automating installations using the Kickstart facility. The idea is to be able to do a completely unattended installation of Red Hat Enterprise Linux. The objectives are to explain Kickstart concepts and the architecture to it, and to create a Kickstart configuration file. We have two sections in this chapter: defining the Anaconda Kickstart system and deploying a new virtual machine using Kickstart. We have a final chapter test that is a quiz on automating installation with Kickstart. So in our first section, we'll do an overview of the Kickstart system. Our objectives here are to be able to identify the key configuration elements of Kickstart and a Kickstart configuration file. If you slide a DVD into a brand new system to start to install the Red Hat Enterprise Linux operating system, you'll boot up into an interactive installation where there are quite a number of questions that need to be answered, including what's the machine name and IP address, what time zone are you in, how do you want to partition the disks, what's the root password, what packages do you want to install. And it's not a difficult process, but it can leave you tied up at the machine for a while. If you multiply that by having to install, say, a couple of machines or a dozen machines or hundreds of machines, you can see that this can be time consuming. And even more so, the idea that if you're going to do this 100 times, I guarantee you're going to forget something or do something wrong. So the idea of being able to automate it and put it in a configuration file allows it not only to make it easier and to be able to multiply it many times over faster, but also gives you reproducibility and confidence that it's accurate, and once tested, it's exactly the same when you build many machines. So we do this with a facility called Kickstart. If you are familiar with Microsoft Windows, you might have performed unattended installations that also use an answer file full of options. If you come from other Unix environments, possibly you're familiar with the Solaris version, which was known as Jumpstart, which also allows you to make answer files that have all the prompts and all the answers to them that satisfy all the questions that come up during an installation. So these configuration files are then read by the installation program, and as long as everything's in there that they need, the installation program does not have to come back to the installer to ask other questions. The name of our installer in Red Hat Enterprise Linux is called Anaconda. That's actually the program that does the installation. And it's Anaconda that does that work of driving the whole installation, whether you're using Kickstart to automate it or if you're doing it manually. And in fact, there's an interesting idea to present about the architecture of this that will help you find other uses for this. This can be used to automate any kind of installation. So I've made a drawing on the board to show the similarities between the different types of installations. So starting on the left here, this outer blue box just being a physical machine, if I were to want to install a single standalone machine, I can go grab the DVD. This red circle is a DVD. I can grab a DVD, boot my machine off of that DVD, and that will automatically take me into the Anaconda installation, and it will require me to answer all the questions. It will prompt me through for the things like partitions and packages and layout and all the rest of it. So it will take me through the whole installation manually. But there's another way to do it. You can have what we basically call a network Kickstart server. And the idea of a Kickstart server is that if I take that same DVD and I share it using NFS or I share it using HTTP, we can use any sharing protocol. If I share that, then I can invoke that across the network. I could do, for example, a firmware-based Pixie boot, which does a network boot looking for an installation server. I could do a network boot off of this DVD, and again, When I boot off the DVD, it takes me automatically into a manual Anaconda installation. Now, on a normal Kickstart server, we normally copy the files off of this DVD and put them on the hard disk for performance reasons. And also, you should know that you've already learned Yum in the System Admin 1 class and what a repository is. The actual packages are actually on here in Yum form, as a Yum server. So copying this and putting it on a DVD basically gives us a Yum server that has all the packages that were on the DVD, and it gives us all the infrastructure that allows you to do a network boot. Okay, in summary, the point is, whether you start an installation locally by using local media, or you start an installation by using remote media, it's the same thing. And either way, that's going to take you into an interactive manual installation. So this is where Kickstart comes in. You create a Kickstart file. So we're going to do this in this class. We create a Kickstart file with all the answers in it. And we make that available by sharing it on the Kickstart server. And you'll need to know where the location of it is so that you can ask for it as you start the installation. Or you take this same file and you bring it over, and maybe you've got it on a USB key, or you just drop it on the disk in a place where you can find it while you're doing the installation. And you specify this same Kickstart file while you're doing a DVD local installation. It's the same thing. The Kickstart file has all the answers and can be used to automate any type of installation. Again, in summary, my point is most people think about Kickstart files as something that you only use with Kickstart servers, that you only use when you're doing a network-based install. But that's not true. Once you've created one that works and does the kind of installation that you want, you can take any standalone machine, grab the DVD and the Kickstart file like on a USB key, and use them together to automate a standalone single installation. Like if you're practicing with a spare machine at work or with a spare machine at home to get in practice from this course, you would start off and build a machine this way using the same Kickstart configuration that you're going to start building here in this chapter. Further, when you want to go build virtual machines on top of your base machine, so you want to kick off more KVM instances like we learned in System Admin 1, you would install those the same way. You would use the combination of the DVD and the Kickstart file to automate the installation of the KVM virtual machine, the guest machine. So that installation is identical. So realize that, again, the installations are exactly the same. The difference is just where am I finding the files? Are they on a remote server? Are they local? And especially when you're going to build a virtual machine, same thing. We could use it as a network install from a setup Kickstart server, or we could build this virtual machine using local media. It's the same thing. So this Kickstart file is kind of important. So let's take a look at the contents. What do we actually have in here? So there are a list of commands that define how the target machine is to be installed. And as they point out here back in the book, anything that starts off with a hash is a comment. Anything that starts off with a % is a directive that is a section. And you'll notice that these sections begin with some keyword and end with this %end directive. So you'll see that as a section of grouped parameters that belong together. One of the sections you'll find is the packages section, which actually states which RPM packages you want to install, and it includes stating what the core grouping of the type of installation you're putting together. The other thing that you'll see usually down towards the bottom is possibly a pre-section and a post-section. Now these are scripts. They're actual scripting language. When this gets invoked, we actually take that whole script section and literally turn it into a script in memory and run it. So what you're putting in this section is any kind of coding. I mean, if you can script, you can do anything in these sections. The pre-section is tasks that you need to perform before the installation starts, and sometimes you have special tasks to figure out what kind of hardware you have. It's not usual, but something that has to be run or configured before allowing the installation to start, like maybe doing special work to prepare a disk before the installation gets a hold of that disk. The post section is more common though. Once we get the operating system installed, you can finish the installation by manually configuring or setting up users, or well, we can do that in the Kickstart file itself. But anything that you can script that you want to do additionally on top of a system to automate it so you don't have to do it manually after you've rebooted can be done in a post section. So if you can script it, you can do it in the installation. So let's look at some specific syntax that we actually use in the configuration file. That, notice as we go through the idea is to give you an example of the type of things we see in there. What we're describing here is not completely inclusive. It's not everything. You will use the documentation, both the man pages and the PDF documentation from the Red Hat site, to find out what all the options are and to find full descriptions on every option that's available. So again, the idea here is to show you some examples. So if you're doing a network-based installation, you would point to a URL that says where is the root directory of the tree structure of the DVD itself. Where is that found? And for example here, that could be on an FTP server at this location. So you've already set up that server, made it shared with FTP or HTTP, and made it available. Now we just need to specify it in the Kickstart file. Now that URL points to the base of a DVD structure that includes the files necessary to boot up and get into the installation. Afterwards, later on, as we're installing and we need to start installing RPM packages, we need to point back to a repository where all the rest of the packages of the installation will be. And that is this, repo equals and base URL option equal to point to repositories. And also, this could be pointing to additional repositories besides the base to get additional installation software for other, advanced packages, things beyond a normal base installation. You can perform your installations both in graphical mode and also text mode. They tend to run roughly the same speed, but usually you choose this based on the amount of video memory that you have available on the system to save memory, not to be faster necessarily. It's roughly the same speed, but to save memory, many times we force a text mode so we don't have to load the graphics. And there's another trick. It's not that common, but it's so useful if you try it. You can set up the installation to be connected to by VNC. So the installation kicks off, and you would use a VNC client to connect into it and be able to watch and manage it while it's running. So the idea that you could be connecting into the installation from a remote machine to watch the installation while it goes on. So if you set that up in the Kickstart, it will set up the VNC, the server side, or the VNC tools on the installation side that are ready, and also you might want to give a password to make sure that only authorized people can connect to the installation and manipulate it. As far as partitioning goes, preparing a disk, we need to be able to decide what we want to do with a disk, and it may be that the disk you're about to install on has been used for another purpose. So usually we take over that disk and wipe out anything that's on it. That's most common, especially if you're taking a pre-existing RHEL machine and just reinstalling it cleanly for any purpose. So the first thing we do is go into the master boot record and actually do this clear part, which gets rid of the partition table, the label area of the disk, wipes it clean. Then we come back and say what kind of partitioning we want. As far as individual partitions, we can declare them and say what their mount points are, what their file system types are, what size they are, whether or not they're allowed to grow during the installation. Grow means if I were to have a certain size disk and dedicate a certain part of it, let's say to the root partition, I might make another partition, and by specifying the grow option, I allow it to figure out on its own what the remaining size is and grow up and take it all, instead of saying let's give it a fixed size. During installation, you may have multiple disks, and this, things like USB keys plugged in. You may have multiple disks available, and you are trying to install only on a certain disk. So we can ask to ignore certain other disks that we don't want touched, that we don't want overwritten. So that will allow us to preserve things that are installed on certain drives that are, built into the machine and cannot easily be removed. Bootloader allows us to specify where we put, what is fundamentally the master boot record, the boot block that boots the system. And we have this choice because it is possible sometimes that the bootloader goes on a separate physical disk than where the actual root partition is. And under normal circumstances, you may be familiar with the root partition being the same as the boot disk, but at least this gives us a choice of where you put it. Now, logical volumes, the vol group and the log vol options. We normally do not install anymore into raw partitions. The problem with setting up raw partitions on a disk is the fact that they're not resizable. After you've installed, those sizes are fixed. They can be resized, but it's kind of a complicated process to be able to resize partitions. So you'll notice today, all Red Hat Enterprise Linux installations by default use logical volumes. We fundamentally create a boot area and then use the rest of the disk as a volume group. This allows us to create volumes that later on can be resized easily. That's the nature of logical volumes. So you'll see, PV, physical volume, VG volume groups, and LV logical volumes as the construction inside almost all of our default Kickstart methodology. For the network, we can specify which device to use. Is it a static configuration? And we can even put the actual static configuration in. Is it static? Is it going to use DHCP? Is there anything else we need to know to make the network come up the first time? Do we want the firewall turned on? Now, it's kind of a nice idea that you enable the firewall right from the installation so that your machine is protected immediately, that there's no, open time between installation and the rest of the configuration where the machine is vulnerable, where somebody might mess around with it. But we do need to have certain normal services open so that you can get into the machine easily. So we default to enabling the firewall and asking for basically just SSH access and CUPS printing access and letting everything else be manually configured later. Of course, you can extend that. You can set the language and the type of keyboard and the location of where the machine is by setting the time zone and also pointing to any time servers. As far as users go, you can say that you are using local users or you can use LDAP. You specify that with the auth keyword. And you can define the initial root password right there in the file. Now, it can be encrypted. In this example, they're showing it as plain text. From a security standpoint, that's usually not a good idea. But we have a command that allows you to type in any, whatever you want to use as a password, and it will return to you the encrypted version, which you can then take and just cut and paste, as you see here, into your Kickstart file to say what the password is, but to have it protected even in the Kickstart file showing the encrypted form. And of course, even the Kickstart doesn't need to understand what that password is. It will take this encrypted form and just copy it straight into the etc shadow file for you during installation. Now, SE Linux protects our system from misuse, so it's always a good idea to make sure that SE Linux is enforcing, but this allows you to set other attributes of SE Linux during the installation. You can choose what services, what daemons and processes are going to be automatically started on boot by declaring either, both those that you don't want that would come up by default that you now want disabled, and those that might be disabled by default that you want enabled instead. Anything that is already designed to start on boot in a regular installation doesn't have to be specified. There are a lot of defaults that come up on their own. So this is only modifying those that you either want to disable different than the default or enable different than the default. It is also possible to actually create new groups and new users right here during the installation. So you just list those. And if you want to modify parameters, you can specify non-defaults like, forcing a group ID or setting a password or, what group memberships the users have, and just list them right in the file. And logging. You can define how our syslog does logging, and one of the most common ones here is in a production network. We usually have our syslog point to a standardized centralized log server. So here's example syntax for how you would do that. Now finally, there's at the end of the installation, after you reboot and come back up, there's this program called First Boot, which does finishing configuration that is required, that can only be done after the machine's installed and done and booted normally. So the program that handles these things is known as First Boot. And First Boot, for example, might ask you if you want to create more users, or if the root password hasn't been set yet, it might ask you for the root password, or to prepare the kdump area. If you have no need for that additional stuff, if everything's been configured in the Kickstart file and you don't really want the First Boot program running, we can disable it. Finally, there's a directive that says, what do we do when the installation is done? Normally the default is just to let the system reboot, come up the first time. But you can also let it finish and just power off or halt it. You might especially be doing this if you're building this, if the machine you're building is to be used as a template for other machines and you do not need or want it booted yet. So just, that was just an example of some of the directives. Here's what a Kickstart file looks like in total. And if this is the first time that you've worked with this one's pretty small and simple. They get more complex, from here. But again, you'll notice that as you walk through here and look at these options, all of them are fairly simple to look up and to understand, each purpose. And each of these correlates to a question that's asked during the manual installation. So I would suggest that if you have practiced on a local machine, booting off the DVD and performing a manual installation a couple of times until you're really comfortable with the full procedure, then when you start going through a Kickstart file and looking at these options, you're going to recognize them as direct answers to questions that come up during the manual Anaconda installation. So here's all of our questions up top that give us partition sizing and machine network configuration, the root password, what services, as we've just discussed. Then here's the packages. We're saying there is a package group called core, and there's a lot of packages in it, but you can choose the basic type of installation as long as you know the name of the group you want. And then the rest of these are additional packages to add on top. I also want to install these. And anytime you put in a package with a minus sign in front of it, you're saying, but I want to remove these. So it looks like Network Manager and Plymouth come in the core, but for this installation, they didn't choose to, they didn't want them, so they wanted to make sure that they were not installed. So that's what the negative sign means. Finally, as we discussed, the scripting sections. In this case, there's a post. This whole thing from right here underneath post all the way to the end, which this one's kind of short, you'll notice it looks like a script. It is a script. And it does actually need to be proper bash or Bourne script syntax. So the installation, Anaconda will actually cause this to be, kind of grabbed and turned into a script. We'll load it into a process structure and invoke it as if we'd loaded it as a script file. And it will go and run at the end of the installation to do any additional things. And really what we're doing here is anything that we couldn't quite figure out how to do with proper Kickstart syntax. But it's a script. You can do anything. So you're only limited by how good your scripting is and what you can think up to get done that's necessary. So that's it. If you make a mistake in your Kickstart configuration, it's usually not catastrophic, but if the Anaconda installation cannot find a particular option that it needs. It needs an answer to a question, and it doesn't seem to find it in your Kickstart file. It might just be a spelling mistake. Then you'll notice that Anaconda will come up and ask you for that option, or you'll see, as we do the practice a little bit later, you'll see the screen where you have these icons for going in and doing the different sections. And it will come up with an icon that shows that the section requires something, and you'll have to manually go in and handle that. So the way to test your Kickstart configurations to see if they're working is to actually go try and install with them. And once you get to a point where the installation can go from beginning to end without asking questions, then you've gotten all your syntax correct, at least up to that point. Okay, let's take a look at the practice for this section, a quiz. You have some descriptions to correlate to the names of different sections or options within Anaconda. Take a minute to do this quiz and pause the video. When you're done doing the quiz, come on back to the video and we'll go through the answers to the quiz. Okay, let's go through the answers to the quiz. So the first description, the section of a Kickstart configuration file that specifies what software is installed on the new system is the packages section. That defines the package groups that are the base installation plus any additional packages. The required Kickstart command that configures how users access the system, that's auth for authentication, specifying local or LDAP or Active Directory, for example. Location of the software used by Kickstart to install a system. That one is the URL. That will point to a location on a server, or it can actually point to a local CD-ROM, for example, but it points to where the location of the files that will start up the Anaconda and get you into the installation program itself. Scripting in a Kickstart configuration file that is executed after the software is installed, that would be post. Because you have a section called pre that can be used before the software is installed, but this one they're asking for is afterwards, so that would be the post section. Kickstart command that specifies which partitions should be cleared before installation, and that is clear part, short for clear partition. Modifies which services will be started by default at system boot, that is the services directive. Next, the Kickstart command that specifies the size and format and name of a disk partition is part, again, short for partition. The Kickstart command used to specify NTP servers, that's basically your time stuff, so that would be the time zone directive. And finally, determines the network configuration for the installation and the target system. That one is network. So that's it for all the choices in the quiz. Now that we're done with this quiz, we're done with this section, and we'll start a new video on the next section.